Bueno, un placer estar aquí. Muchísimas gracias, SAP. Y quiero dar las gracias a Fernando y a Marcia por haber estado todo el rato ayudándonos y conectando con nosotros. Creo que hemos tenido un panel de speakers aquí que ha sido increíble. Yo he estado aprendiendo muchísimo. Hemos llegado y estaba en consonancia con todos vosotros. Es que es increíble, ¿no? Y normalmente cuando doy charlas sobre el MIT, hablo muchísimo de colaboración, de poner al ser humano en el medio. La tecnología es simplemente una herramienta, ¿no? Y cómo podemos colaborar con la gente que normalmente no colaboramos, lo que llamamos los unlikely partners, gente que nos cae mal, ¿no? Cómo podemos trabajar con ellos, porque ahí es donde surge la innovación. Pero esta charla la he orientado un poquito más hacia otra dirección, que es soluciones hiperlocales para retos globales. Veréis entre líneas que todo esto que hemos estado hablando hoy aquí está ahí embebido, pero quería centrarme un poquito más en esto. No sé quién sabe más o menos qué es esto de 2,5. ¿Alguien? ¿No? Bueno, pues este 2,5 es las emisiones promedio de CO2 que cada habitante del planeta puede producir cada año para que en 2050, ¡tachán!, podamos tener un 80% de posibilidades de limitar el calentamiento global en 2 grados centígrados. ¡Wow! Eso suena como súper potente, pero a la par, ¿esto qué significa? Cuando hablamos del cambio climático es súper difícil entender qué significa estos 2 grados centígrados. Y luego ya si profundizamos, nos hablan del crecimiento, nos encontramos algo parecido a esto, ¿no? En plan, sí, va a subir el nivel del mar, sequía, nos vamos a cargar el ecosistema, enfermedades, pero es muy difícil imaginarse esto, ¿no? Lo bueno es que en el MIT llevamos muchos años combinando imaginación, tecnología, ciencia, evidencias científicas para predecir y diseñar el futuro. Aquí no vamos a predecir el futuro, pero quizá podamos explorarlo, tal y cual hizo Nicolás Negroponte, que es uno de los pioneros del MIT Media Lab, cuando en 1968 vio 2001 Odisea en el espacio, Stanley Kubrick, y de repente vio estas tablets en la mesa, ¿no?, de la nave espacial y dijo, ostras, yo quiero hacer esto. Entonces, en 1971, Nicolás Negroponte ya había creado el primer prototipo de Tangible Interface, ¿no? Una pantalla que podías tocar y manipularla, pero en 1984 ya tenía un touchscreen total. ¿Y qué estaba haciendo en ese touchscreen? Estaba haciendo Google Street View, estaba paseándose por Kendall. ¿Por qué? Porque había puesto una cámara en su coche, había grabado Kendall Square y en esa touchscreen ya estaba manejándose y explorando Kendall Square. Bueno, Google Street View aparece en 2007, pero es que el primer iPhone con touchscreen también aparece en 2007. Así que así es como desde el MIT intentamos imaginar y combinar esa imaginación con tecnología para ver qué podemos hacer en el futuro. Así que, bueno, por desgracia, en el cambio climático ha habido otra gente que ya ha explorado por nosotros. Cuando hablamos de incremento del nivel del mar, algunas de nuestras ciudades quizá en el futuro se puedan ver así. Cuando hablamos de sequía o desertificación, algunas de nuestras ciudades a lo mejor se pueden ver así. Cuando hablamos de destrucción del ecosistema, algunas de nuestras ciudades o montes se verán así. Cuando hablamos de enfermedades, bueno, vale, y esto ya nos lo conocemos, así que no hace falta ni siquiera ir al cine para imaginarlo. En el grupo de ciencia de las ciudades, el City Science Group, lo que hacemos, entre otras muchas cosas, es creamos digital twins, básicamente digitalizamos ciudades para poder hacerle preguntas. Eso es lo que llamamos el Cityscope, ¿vale? Y, por supuesto, utilizamos inteligencia artificial desde hace más de, seguramente, 10 años para poder manejar todo ese Big Data y poder hacerle preguntas. Así que lo que hemos hecho ha sido, y quiero que ahora imaginemos todos juntos, ¿no? Hemos tomado Kendall Square, que es donde tenemos el campus del MIT, y hemos dicho, ¿qué pasa si le hacemos un twin digital y empezamos a preguntarle y a medir políticas para reducir el cambio climático? ¿Cómo nos afectaría eso? Para hacer este twin digital, lo primero que hemos hecho ha sido, primero, analizar cómo todo el mundo que vive y trabaja en Kendall Square realmente cómo se mueve y cuáles son sus impactos ambientales. Para ello, hemos medido la huella de carbono. Y sí, hemos medido la huella de carbono de cada uno de nosotros porque cada uno de nosotros tenemos una huella de carbono diferente dependiendo de cómo nos movemos, dónde vivimos e incluso qué es lo que comemos. Así que esto es fundamental. Y luego hemos unificado todas estas medidas en un criterio básico que es toneladas de CO2. Pero hay dos tipos de toneladas de CO2. Una que es el CO2 operacional y el otro es el CO2 embebido. Esto es un rollo, pero os lo tengo que contar. ¿Vale? Entonces, el CO2 embebido es desde que extraemos la materia prima de la naturaleza, construimos el coche, el edificio, lo que sea, lo ponemos en uso y luego lo tiramos o reciclamos. Ahí hemos gastado energía y hay un CO2 que se queda impregnado, por así decirlo, en esos objetos. Luego, el CO2 operacional es cuando utilizamos el coche, cuando encendemos las luces en los edificios, los acondicionamos. Ahí también estamos quemando energía y ese es el CO2 operacional. Lo que hemos hecho es, a través del análisis ciclo de vida, lo ponemos todo junto y con el Cityscope, ¿no? Pues hemos empezado a buscar estos escenarios. A ver, ¿qué ocurriría? Y lo primero que hemos visto es que en Kendall Square nuestra huella de carbono media es de 17,19 toneladas de CO2. Ahí es nada. Tobin, Angela, Hope, lo siento, pero estamos fastidiados. La cosa es cómo llegamos a 2,5 toneladas de CO2, ¿no? Es un reto, y además el reto aquí es que no podemos esperar a 2050. Tiene que ser en 2030. ¿Por qué? Porque no podemos esperar. Así que, ¿qué pasa si empezamos a medir las diferentes intervenciones que son las más tradicionales, como por ejemplo la descarbonización de la red? En Massachusetts propone que para 2030 el mejor escenario va a ser que van a poder decarbonizar la red un 40%. Eso no está nada mal, porque eso significa que vamos a poder reducir un poco más de 1 tonelada de CO2 por persona por año gracias a esta decarbonización. Sobre todo es un CO2 operacional. Vehículos eléctricos. Imaginaros, y aquí estamos todos imaginando, ¿vale?, que en Kendall Square de repente decimos el 100% de los vehículos van a ser electrificados para 2030. ¿Eso qué significa? Pues que vamos a reducir el CO2 operacional, porque los coches eléctricos son mucho más eficientes que un coche de combustión, pero vamos a incrementar el CO2 embebido, porque hay muchos coches que vamos a eliminar antes de que se termine su vida útil, y encima, bueno, pues los coches eléctricos también tienen baterías, etcétera. Así que el balance final no es nada malo. Estamos reduciendo también 1 tonelada de CO2 por persona por año, que es un buen impacto. Sigamos adelante. Teletrabajo. Hemos visto que el teletrabajo ha venido aquí para quedarse, pero en la época de la pandemia todo el mundo decía, no, nos vamos a ir a vivir, ¿no?, al campo y las ciudades se van a quedar vacías. Me encanta esta película, así que por eso la pongo. Pero lo cierto es que, por lo menos en Estados Unidos, si miramos los datos, estamos volviendo un poco a la pospandemia, a 2019, cuando todo el mundo trabajaba desde casa más o menos entre 2 o 3 días por semana. Quedémonos con 3 días por semana. ¿Cuál es el impacto de trabajar desde casa 3 días por semana? Pues realmente podemos reducir 0,35 toneladas de CO2 por persona, que no está mal. Aquí seguimos. Rehabilitación de edificios. Imaginaros otra vez más, ¿no? Pillamos todos los edificios de Kendall Square y lo que hacemos con ellos es introducimos, primero, aires acondicionados más eficientes, iluminación más eficiente, sistemas inteligentes para controlar todo esto, mejoramos el aislamiento. Eso lo que va a hacer es que, por supuesto, vamos a reducir el CO2 operacional, pero vamos a incrementar un poquito el CO2 embebido porque estamos trayendo más materiales al edificio. Vamos a ver un poco eso que le pasa a nuestra burbuja, que es un buen impacto también porque es más de 1 tonelada de CO2 por persona. Eso está genial. Pero ya como que nos hemos quedado sin respuestas, ¿no? ¿Ahora qué hacemos? Ostras, esto es como... Pues lo que hemos hecho en el grupo es decir, bueno, desde el MIT llevamos como más de 20 años trabajando con ciudades, intentando entender cómo crear distritos de innovación, ciudades más centradas en el ser humano. ¿Qué pasa si tomamos esas tecnologías y esas ideas y medimos su impacto ambiental? Así que eso es lo que hemos hecho. Y hay una cosa que es el Life-Work Symmetry, simetría entre vida y trabajo. Esto suena fatal cuando lo traduzco al español, la verdad, pero lo que quiere decir es un poco esta idea de los 15 minutos caminables, que realmente nuestro grupo lleva ya 10 años trabajando en ello, fue bastante pionero en su campo, pero la idea aquí es qué ocurre si desde el CEO de la empresa hasta la gente que cocina y limpia el edificio vivieran a una distancia caminable. ¿Por qué hacemos esto? Porque la diversidad y la colaboración entre gente muy diferente es lo que crea innovación. Pero, ¿qué pasa además con el cambio climático? ¿Qué pasa si tomáramos las 40.000 personas que todos los días viven en una casa en el suburbio muy poco eficiente y van a Kendall Square a trabajar todos los días usando el coche? Y lo que hacemos es que vivan en esos edificios súper eficientes que tenemos ahora ya en Kendall Square, con nuestra imaginación, ¿no? Y vivieran a una distancia caminable del trabajo. Bueno, lo hemos mirado en el Cityscope y la reducción es más de 3 toneladas de CO2 por persona. Esto, por supuesto, es una medida que tenemos que complementar con otras ideas. Bueno, ¿qué pasa si empezamos a pensar en lo que se suele decir comercio de proximidad, ¿no? Y servicios de proximidad? A día de hoy los norteamericanos utilizan el coche para irse a estos grandes malls que además están en decadencia y son muy poco eficientes. ¿Qué pasa si empezamos a traer servicios de proximidad a Kendall Square? Hemos utilizado datos de réplica y SafeGraph para entender cuáles son estos servicios de proximidad que necesitaríamos para fomentar la innovación dentro de Kendall Square y hemos visto que este es como el top 10, ¿no? Esto es como los más importantes. Kendall Square se supone que es un distrito de innovación, pues carece de la mayoría de ellos. Claro, lo que no sabéis es que Kendall Square no es como Barcelona. A las 7, en Kendall Square no hay ni un alma. Está más muerto, vamos. Así que lo que hemos hecho ha sido poner, una vez más, en el Cityscope, explorar estos datos, y esto también podría reducir más de 2 toneladas de CO2 por persona. Así que nos vamos acercando a un punto en el que, para poder tener estas medidas, sin duda tenemos que animar políticas de vivienda. Se está discutiendo mucho en España sobre esto, para que la gente pueda vivir, ¿no?, en los centros de las ciudades. Pero ¿qué pasa si además de esas políticas pudiéramos tener tecnología? Cuando llego al lab, hace 9 años, este es el proyecto en el que me pone mi jefe a trabajar, que era, ¿qué pasa si podemos crear una vivienda mínima en la que se transforme, ¿no?, y tengas todas las utilidades de una gran vivienda, pero en un espacio reducido? Los estudiantes se emocionan tanto que dicen, vamos a meterlo en 20 metros cuadrados. No porque queramos que la gente viva en 20 metros cuadrados, sino porque, bueno, a veces allí pues, la gente se emociona y quiere un gran reto. Y lo consiguieron. Fue un éxito tal que ahora de aquí ha salido un spin-off que se llama Ori Living y que tiene a Marriott, a Google y a IKEA como inversores. Y ahora voy a enseñaros al CEO, que es Asier Larrea, que es un chico vasco, y me gusta esta imagen porque está bailando la conga. Normalmente poner a un CEO bailando la conga no está nada mal. Pues este es Ori, uno de los productos que un tiktokero puso en su red, y esta es una unidad en Nueva York. Yo creo que podría vivir en un sitio así, ¿no? Pues estos sistemas, además de traer diversidad a las ciudades, también nos pueden ayudar a reducir 0,75 toneladas de CO2 por persona. La última milla. Bueno, ¿qué pasa si traemos vehículos autónomos, eléctricos, que cuando no están llevando personas llevan productos y nos ayudan a resolver la última milla? Este es un prototipo que tenemos con la empresa Day0, japonesa, miembro del lab, y la idea es un vehículo eléctrico persuasivo, una vez más, que cuando no está llevando personas lleva productos y nos ayuda a resolver la última milla. Pero, ¿qué pasa si tenemos un ecosistema de micromovilidad? Diferentes vehículos, como esta bici, a lo mejor más para estudiantes, y tenemos diferentes productos en este campo, en el que, como veis, es una bici que de repente se transforma en triciclo y se va a buscar a otro estudiante. Este tipo de sistemas, además, una vez más, de ayudarnos a resolver la última milla, nos ayudan a reducir casi otra tonelada de CO2 por persona. Como veis, casi todos los impactos que hemos tenido aquí son para reducir ese CO2 operacional, pero aún así todavía queda un poco de CO2 operacional, y lo que estamos diciendo aquí es, ¿qué pasaría si la fusión, en vez de venir en 2050, de repente llega en 2030? Pues podríamos decarbonizar 1 tonelada de CO2 por persona, y es que el CO2 operacional es el fácil, es el que es fácil de resolver. El problema es el CO2 embebido. Ahí, desde las ciudades podemos hacer poco, pero ¿qué pasa si empezamos a pensar en sistemas de producción locales? Porque, claro, el CO2 embebido ocurre en los sitios de producción. Así que lo que se nos ocurrió es, ¿qué pasa si trabajamos con la dieta? Hay que tener en cuenta que es que en Estados Unidos la dieta americana ya son 2,5 toneladas de CO2 por persona, o sea, ya se cargan todo el invento. Así que desde hace tiempo estamos trabajando con producción local de comida. Hay empresas que ya están produciendo comida en nuestras ciudades. Eso nos ayudaría a reducir más de 1 tonelada de CO2. Y hasta aquí es hasta donde podemos llegar en las ciudades. ¿Por qué? Porque las ciudades producimos el 75% del CO2, aunque también producimos el 80% de la innovación, todo hay que decirlo. ¿Ahora qué nos queda? Nos quedaría, pues a lo mejor, decarbonizar los vuelos, ¿no?, los viajes en avión, decarbonizar los datos. Por cierto, los datos producen el 7% del CO2 del planeta, y intentar pensar en una producción local de alguno de los productos que a lo mejor ahora estamos produciendo en terceros países, ¿no?, que a lo mejor tiene sentido relocalizar aquí. Con esa medida seguramente podamos ir incluso más allá de 2,5 toneladas de CO2 por persona, pero esto solo son algunas ideas. Yo quiero que ahora, cuando nos tomemos los vinos, hablemos de esto, ¿no? O sea, y podamos modelar vuestras ideas para buscar soluciones hiperlocales al calentamiento global, porque las nuevas generaciones, la verdad es que se merecen, ¿no?, que lo analicemos, pero además que intentemos resolverlo todos juntos. Ahora voy a pasar el micro a Hope, que es una de las... un genio, la verdad. Tengo aquí a 3 genios. Estoy muy contento de haber podido traerlos conmigo. Y Hope nos va a hablar de cómo la inteligencia artificial, cómo se puede co-crear entre los seres humanos y la inteligencia artificial. Así que muchas gracias, Hope. Te doy el... Amigo.
Okay, muchas gracias, Luis. Yo quería dar este discurso en español, pero necesito practicar un poco más antes que pueda hablar bien sobre inteligencia artificial generativa para colaboración y co-creación. Y por eso, por favor, háblame en español después, pero voy a hablar en inglés. So with that, I'm Hope. I'm a PhD student at the MIT Media Lab, the MIT Center for Constructive Communication, and today I'm going to be talking about co-creating across scales with AI. So, some of you may have heard about AI in the news recently. Some of you may have even heard a lot of scary stories about AI in the news recently. Raise your hand if you've heard a concerning headline about AI in the news. That's a lot of us. Me too. I'm actually instructing a course at MIT this semester about advances in artificial intelligence recently, and it basically became my full-time job just to keep up with the current events and the news. And a lot of the headlines out there are really scary. Some people are saying the AI panic is here, and there was even a request by major artificial intelligence people and lay people to put a pause on AI developments just so that we can get a handle on what's going on. Some people even said that this was not actually a far enough request, that we needed to put a stop to all of this entirely. We need to shut it all down. So with all this doomsday chatter, it can feel like AI is coming for us. But what I want to get into is the question of why it feels so personal. For a long time, we had the idea that artificial intelligence was something that could automate processes that were logic-based or mathematical. But really, as humans, we were still able to hold on to the things that we do best, like expression, like creativity, like relating to each other. The scary thing is that now it seems like AI can do some of those things. Maybe you've been able to play with a text-to-image model that generates an image or even creates a poem for you. So that can make it feel even more like AI is coming for our humanity. But headlines like these don't help, do they? So this provocation basically is putting the idea in our heads that the world's smartest artificial intelligence created its first magazine cover. This is a famous magazine in the US, Cosmopolitan magazine. But let's look a little bit beyond this headline, because the artist is much more involved in this than you may think, based on this headline. How does something like this get made? Is it artificially intelligent? Is it even smart? We're going to take a look. So first, how does this model work? A human artist gives an AI model, called a text-to-image model, a prompt. This artist said, astronaut woman on Mars. Then the AI model gives a bunch of versions of an image that the artist can then work with. Then the artist picks one, does a lot of editing, synthesizing, collaging, remixing with other things before you get this final version that is very beautiful and is on the cover of Cosmopolitan magazine. But hopefully this explains to you how the story is a little more complicated than the magazine headline would make you think, because the human artist created this cover with the help of AI, but they were still in control. So I would put to you that this is not the first artificially intelligent magazine cover, and it was still created by an artist. So, with that idea, is AI actually coming to take our humanity? I would like to put to you that we can use generative AI as a tool for the good of humanity. And we're going to talk about how that looks in a few examples. So the first paradigm for co-creation with AI is at the smallest scale, where a human, like we just saw with the artist example, uses an AI tool for image creation. So here you have an artist here who has an idea. She says, I want to see an astronaut in space with a pink sky. She gives it to the AI model, sees a lot of different versions, and then can do whatever she wants with it. So why is AI good for this task? Well, first of all, it makes creativity more accessible than ever. I assume that some of you in this audience might not consider yourselves artists, but the exciting thing is that anyone can play with these tools. Anyone can use DALL-E or Stable Diffusion, and just typing in what you want to see, you too can become an artist. The next exciting aspect is that ideation is faster. So the artists that might have taken a minute, days or hours to create a single image can now prototype faster and move through their ideas faster. These are really exciting advances. So we wanted to know, how do we actually use these in practice? We wanted to know at the MIT Media Lab, do AI-generated images actually affect what we make in real life, off the screen? So it's all fine and good if it stays on our screen or we circulate it online, but how does it affect what we make in the real world? That's an experiment we wanted to do. So this first paradigm, where we have an artist creating images, we then wanted to give this artist, or the participant in our experiment, some tools to create something in real life. And that's what we did. The artists gave ideas to the AI model, they generated some images, Then they actually built a sculpture using some fun materials that we provided on hand. Here's a few of our happy participants making their sculptures. And this allowed us to investigate and find out some interesting things about how AI can help in the creative process. One is that AI-supported brainstorming affects the design of physical objects. So on the left, you have this AI-generated image of some buildings, and on the right, you have the sculpture that a participant in our experiment created. As you can see, there's some exciting similarities. So on the left, you have these white buildings and a red roof. On the right, you have a white building and a red roof. You even have the little shiny river and the little grass. And with the materials that we provided, this person made a little grass bed out of foam and a CD. So the findings from this experiment tell us that this is not going away. 75% of participants said that the AI-generated imagery actually affected what they created in real life. And 93% of participants said they would like to use an AI tool like this again. Combining this with what we know from the news, these tools are not going away, so it's really important to think about how we can use them in our everyday life. The next question we had was, why are these AI-generated images useful in brainstorming? So we did another experiment. The next paradigm, so we had an artist interacting on their own with the AI model. We wanted to see what would happen if we had people have a conversation together. Then they generate ideas together, give them to the AI model, and then finally they reflect on those images and see what ideas they get from that process. So we had people have a conversation about the future. I know we're talking about future-proofing here today, too. So we had two people have a conversation and come up with a vision they wanted to see in the future. This group of people had a vision for a biophilic garden that could make their neighborhood more beautiful. We gave it to an AI model, which generated this image, and then we had them reflect on it. The interesting thing is that we found that these images actually sparked new implementation ideas. So someone who reflected on this image noticed that there weren't any pumps or tubes. You might expect that the engineering challenge involved in creating a hanging garden would require you to have some pumps or tubes, but this gave the person the idea, oh, maybe we can make it more beautiful than I expected. Another finding was that these images sparked association with unexpected concepts that they previously hadn't been thinking of. So this person was trying to visualize what a public space and an ocean vista would look like. But you'll notice that there's no ocean in this picture, which you might think is weird behavior from the AI model. But the insight this person got from seeing the centrality of relationships in this image made him remember how important organizing is to complete public space projects like this. So we actually thought this was a helpful outcome. So we've zoomed all the way in from the human and AI level. Then people are having conversations about their work. What does this look like if we zoom out to the organizational level, which I know a lot of you are thinking about today? What if we have a group of people who are having a conversation about their organization, then they use the AI model to generate images that can help them figure out where they're headed in the future? That's what we were wondering about at the MIT Media Lab. And like many organizations, we sometimes have to revisit the strategy and vision for the organization. So last year, we came together as a group, we revised our mission statement, we took pieces of our mission statement, gave it to the AI model, which gave us crazy imagery to reflect on, and then reflect back out. So why was this useful? Because organizations and communities can use it as a starting point to think about their collective futures. We actually created a magazine with some of these images in it, which was a really fun piece to create together and then reflect out. We were able to distribute it with stakeholders and communicate what the vision of the organization would be. So what are some findings for organizations that you all might be interested in? Why should we be using generative AI? Well, one is accessibility. Anyone can use it, and creative access is more widespread than ever before. Second is speed. You can prototype quickly things that could be brought into the real world and even start new conversations with people faster than ever. For organizations specifically, though, we think these images are useful as a starting point for internal reflection about where your organization is headed, but also as a way to reflect outward and communicate outward about where you're headed once you've decided that internally. So we started way small. We started with the humans and the computer. Then we had conversations in small groups. Then we had a conversation in organizations where we're reflecting out on the mission of our organization. What does this look like if we go to the citizenry scale or the city scale? Well, a recent workshop did just that. What does co-creating the future of cities, which Luis is interested in, look like? We brought together a group of people who were trying to imagine what their city could look like in the future. The prompt that they came up with was future learning with animals, technology, sharing people with diverse backgrounds are trusted and comfortable, humans and animals together. So some of these images were pretty crazy, and you could see some wonderful visions of human and animals coexisting together. But maybe these are just pretty pictures, right? This is a wacky picture. Why does it matter? Well, it matters because our research shows that AI-generated images introduce new ideas for what is possible and what could be created. 2, what we visualize affects what we create in the real world. We found that with the sculpture example. And 3rd, they can help people align on a vision within a company or even in your entire city. So we've been talking about the text-to-image space. Images are 2D, but it gets really exciting because we're actually on the cutting edge of being able to do text-to-3D modeling. So what does that mean? That means anyone could, as easily as creating an image, create a model of a building or a model of a sculpture that appears in your public space. And it's really exciting to think who might be involved in the creation of our civic infrastructure and our shared spaces if anyone, not just an architect, but even me, could create prototypes like this. This took me 30 seconds on my browser to create little prototypes of sculptures that we could have in public space. So we think this is an exciting horizon for who might have access to thinking about the future of our cities and public spaces. So what do we want to take home from all this? Well, first of all, human control and expression can be at the center of co-creation with AI tools. In fact, it has to be at the center of when we're thinking about the future with AI. And there's a lot of scary information out there, but I hope this talk has given you some ideas about how human expression can actually be elevated and amplified with AI if we design it correctly. Thank you so much. Okay, next I would like to introduce my wonderful collaborator and lab mate, Tobin South, who is an expert on AI and Web3, as well as being one of the most multi-talented people I know. Take it away, Tobin.
Thank you. I want to talk to you today about trusted networks, which is a weird title, and how that maps to this concept of Web3 that seems to be out there. Hope's just told you that the future of AI-human collaboration is co-creation. It's about working together and keeping a human in the loop. But let's not forget that co-creation is still the future of human-human creation. We still have to work together. But underpinning working together is building trust, is having systems that allow us to work together securely and safely. Now, who here's heard of Web3 as a term? A few hands. It's a weird term, has many definitions. I define it, and we at the Media Lab define it, as building secure, trustless systems, typically for the exchange of value. Now, trustless is a weird word, but it means building systems where you have the confidence that everything will go okay, so that you can indeed work together and build trust. Now, you've probably heard about 2 of these trustless systems, Ethereum and Bitcoin. I'm just going to assume everyone's heard about them. They are old news. We're not going to talk about them today. In fact, we're not going to talk about currencies at all today. What we want to do is take the lessons from these technologies and apply them to the way we do everyday business. So, what does that look like? I'm going to talk to you about 3 topics: standardized interoperability, secure data collaboration, and trustworthy network identities. Let's jump in. Standardized interoperability. This is the Ethereum logo icon. And it, as an ecosystem, is self-contained. As long as you're staying within Ethereum, you can do incredible things like collateralized lending, governance and treasury management, dispute resolution and arbitration, things we do in the normal everyday world that run fully autonomously and securely. Now, there's hacks and issues, but this is an incredible code base that people have built that we can take lessons from. So, the first step we need to do is connect this to the rest of the world, whether it's Bitcoin or whether it's the euro. That is easy. We've got exchanges, they've tried to do that. We also need to connect it to data, to the documents and assets that run our normal world. If you're going to do dispute resolution, you have to connect it to the things you're disputing over. And we also have to connect it to the companies that end up mattering, like SAP. So, how do we do that? Well, At MIT, we're working with the Internet Engineering Task Force, who pretty much set the standards of the internet, to build standards that regulate how we transfer assets between things like blockchain, extremely securely, that can be currencies or assets, but also to offline databases and tools that you actually want to use as existing businesses. So, let's jump into secure data collaboration, another weird topic. We've got standardized interoperability to talk about data collaboration. We at MIT really believe the future of communities and organizations is securely sharing data. We all know data is going to run the future, but how do we actually use it? Well, there's many, many tools that we're building, like AI-mediated data analysis, community data pools, private data collaboration technology, lots and lots of technology. So instead, let me tell you a story. Who here's a lawyer? Come on, admit, let the truth come out. We've got a few lawyers in the room, I'm sure. Let's imagine a young lawyer wants to prepare a case. The data that they need to prepare that case is distributed amongst case files that they probably have themselves, example precedents across your own law firm or other law firms, or public facts out on the internet. Traditionally, we would have to put that all on your laptop so you can load it in and do everything. We don't need to do that anymore. We don't need to bring the data together. We can send our tools, our data analysis tools, our AI tools for writing, to the data to examine it as we need it. Distributing this data means we keep security alive by not pooling all the data and creating risk. Now, a key aspect of this is that this lawyer is using cryptography, distributed insight mining, decentralized access control, all tools pioneered in Web3, without needing to know what Web3 is. It's about building private, secure, and compliant systems from the get-go without needing complicated Web3 crypto interfaces. So, what does this mean for all of you? We are in Europe. We have GDPR here. GDPR requires you to share insights, not data. As soon as you take data off someone's device, you have all manner of compliance problems. But if we distribute our data processing and AI across devices, sharing only the insights that you can extract from a user, that is GDPR compliant. You can still have insights and data mining being done. Letting go of that data is in fact a value add. You build trust with the consumer, and you're able to do something with it that's interesting while answering the needs of the consumer. It's a win-win scenario as long as you're willing to embrace these cryptographic and AI tools. Let's jump to trustworthy network identity, a weird title. So, how do we authenticate that someone is real? What doesn't work? Any picks? What doesn't work? Any guesses? No, no one's brave enough. A voice, we can now deepfake a voice very easily. We can also deepfake videos or images, like our friend Einstein here from my earlier talk. Or we can use Apple or Google ID. Twitter tried this, failed horribly. Remember the Elon Musk debacle with authenticated, verified accounts? We could try CAPTCHA. I'm not a robot. GPT-4 was recently used to fill out a CAPTCHA, and it couldn't. It's a robot. So it hired someone on a gig working platform to click the little squares and said, I'm blind, I can't answer this. It convinced a human to click the CAPTCHA to figure it out. So that's not going to work. So how do we authenticate it? Well, we can see someone in person, like we are now. You're all real person. Are you real? You seem mostly real to me. This is a pretty expensive interaction, doesn't scale well. Instead, we can be a bit fancier. We can build networks of trust and reputation. Now, this is not as scary as it might sound. It's a bunch of code that allows us to connect up our data on people to verify our trust in them. Now, the key feature of this is verifiable attestations and zero-knowledge proofs. Who's heard of a zero-knowledge proof here? Like, honest question. We've got one. Anyone in the back? You've heard of AI, I presume, or large language models. In 10 years, I promise you will hear about zero-knowledge proofs as much as you are hearing about AI and large language models today. Here's what it lets you do. If you have a user that is connected to important companies in their life, SAP, credit bureaus, technology companies, we can package that information to say we all trust that this person is real and that they have creditworthiness or the ability to exist on online platforms, they're going to produce trustworthy content. We can package that up with cryptography and send that off securely to anyone without needing to interact with all these platforms all the time. That's called a zero-knowledge proof for an attestation. I assure you you'll hear about it a bunch in the future. So, those are just 3 interesting lenses in which we can take the technologies of Web3, package those technologies into real products that you can put into businesses without needing to confuse consumers. So the key message is this idea of trustless systems, secure systems built from the get-go to always work and be verifiable, are the secret to building better human systems where we can all work together, especially in an age where AI is changing the world rapidly. Thank you very much. I would like to introduce Angela, who is by far the leading expert that I know in brain-computer interfaces and also human-computer interfaces, which are fields that are crazy. She's going to blow your mind.
Thank you so much, Tobin, and also incredible presentations, everyone. I am so grateful to be here. Se dice buenas tardes o buenas noches at 7 p.m. Wow, that means still early in the day. Buenos tardes, my name is Angela Vuich, and I'm a PhD student at the MIT Media Lab. Today, I'm going to zoom all the way back in to the individual level, and then we're going to zoom in even further to talk about our brains and our stomachs. So I would really like to discuss how today's devices, our smartphones, particularly our laptops, etc., they put the world's information at our fingertips, but I'm wondering who finds them disruptive? Anyone? Is your cell phone distracting? You know, does it stress you out? There's a lot of research coming out now that our smartphones, though they were very optimistic and well-intended technologies, they are becoming disruptive to our creative abilities, our ability to focus, and in some cases, our well-being. There is an incoming or ongoing mental health epidemic now in the United States and in many parts of Europe, where in the US, 32% of adults, and in Spain, 22% of adults report having anxiety or depression. And the ongoing treatments for these, like medication and therapy, they are limited by adverse side effects, lack of access, and also long-term failure rates. So there's this question and this interplay between our disruptive smartphones, our mental health issues, and everything. How can our devices do better for us and actually serve us in the way that they were supposed to? So at the Fluid Interfaces Research Group at the MIT Media Lab, where I'm coming from, we really want to help people rethink the role of technology in our lives and to think about how the everyday things we use, like eyeglasses, headbands, smartphones, wristwatches, can be used to improve our cognitive abilities and also our health. So what we do is we look at numerous sources of data from the body and the environment, and we create real-time sensing and also modeling of the brain and our health that can then be used to create real-time interventions in the moment when people need them. So to be more specific of what I'm interested in this talk is I'd really like to talk about how our devices can make us happier and healthier. An example of how we could rethink a pair of headphones is a brain-sensing pair of headphones like the ones from Neurable that are able to detect your brain signals and then subsequently, that are able to detect your brain signals throughout the day while you're working, and then at the end of the day can provide estimates of the times when you were best performing, and then you can learn more about yourself and also improve your attention and performance throughout the day. Another example is how a ring, which is very small and comfortable, and many of us wear every day, can sense heart rate and activity levels, and then further, can be used for sleep tracking, which is a huge pillar of physical and mental health. And then also, it can even be used as birth control for women. And if you're curious about that, you can talk to me after. So going back to research at the MIT Media Lab, I want to tell you about 2 projects that exemplify how we think there are novel, unexplored areas in ways that our technologies can create interactions that improve our health. So first is Serosa. And this project is inspired by the gut brain. So for those who don't know, there is not one brain in the body, there's actually 2. And the second one is located in the gut. The stomach, the intestines, the liver, etc. Those are actually neurons that act without any input from the brain. They exist completely autonomously. And then what's really interesting is that the health of your gut affects the health of your brain. And this is actually the microbiome, et cetera. It's becoming a big area recently. So some people may already know this, but for those who don't, your gut health is very important for the health of your entire body. So what Serosa does is record activity from these neurons on the surface of the skin. And then what you can do is you can look at information about your digestion, your health throughout the day, and this is just an example of the kind of signals you would see the stomach create after a meal. So with this, we can create what I call gut-brain-computer interfacing, which is a new way to interact with technology in which you prioritize your gut health and you use information about things like your stomach to make decisions like exercise, take medicine, etc. An example of what this might look like in real life for someone is the following. Let's say Noor, who is a software engineer, just had a big lunch, and her signals look pretty normal. This is what a normal signal would look like. And then she starts work on a stressful project, and it causes her signals to become dysregulated, faster, different frequencies. And this is actually, I'm showing you data from our study when we had people who ate and then were under stress. So what happens is when you have signals like this, it can have downstream negative impacts on your whole body and also your mental health. So a device like Serosa can detect that this is happening and then subsequently give you an opportunity to take a walk or do something to regulate your signals again. So going from the gut back to the head brain, I'm going to talk about Joie, which is a brain-sensing headband that can teach you how to control your emotions. So many of you may recognize this. This is the human brain. And specifically, the frontal region of the brain is really important for executive functioning, doing things like making rational decisions and also controlling your emotions. And I think what's very important in the context of mental health and also in the context of what I was talking about with the anxiety and depression epidemic, you can train this region of your brain to help you feel happier. You can actually train the left frontal region of the brain to improve symptoms of anxiety and depression. And we found in our studies that doing things like imagining traveling, relationships, achieving goals, and even your dog can help activate this brain region. But the problem is that even if you imagine walking your dog in a park and you activate this brain region, it still isn't possible to improve your symptoms of anxiety and depression unless you practice doing this very consistently over multiple weeks. And so a way to make this easier is first you take something like a brain-sensing headband, and then you connect it to a virtual world where your brain signals are represented by this character running through a field. And then what happens is the more that you're activating the correct brain signal, the more your character is collecting coins. And eventually, your brain is able to learn the association between all these things. And we ran a placebo-controlled trial in which we had people looking at both real feedback and fake feedback. And what was super interesting was that we found that even when people were rehearsing the correct mental strategy, they weren't able to get the correct improvement in brain activity unless we were giving them the JWA system, which is super interesting. So yes, our devices can do better. And also, from the data perspective, very relevant to SAP, because I know more and more there's going to be a lot of wearable data stored on the cloud, we can use this data to create new insights combined with AI on preventing problems. And in particular, there is a very alarming recent study showing that cancer is increasing in adults under age 50, which is worrisome because, of course, it was traditionally associated more so with old age, and it still is. But since 1990, the rates have been increasing dramatically and very alarmingly. And so there's this question of how do you figure out what's causing this unless you have data recorded from people every day through something like a wearable, which over time can give you information on what may be going on. Let's say if somebody has a genetic predisposition to stomach cancer and they wear something like the Serosa wearable every day, they could perhaps catch the cancer sooner than if they weren't doing that. So my belief really with the kind of work that I'm doing and also the kind of work that my research group is doing is that in the future, we're going to be prescribed wearable technology from doctors. So in addition to medicine, or maybe even as a replacement for medicine, I think that these technologies have a lot of potential to really revolutionize the way that we treat ourselves and take care of ourselves and the way that we look at health. So instead of disrupting our lives, they can make us live happier, healthier, and longer. Thank you so much.